Hi there. Welcome to Ancient Cosmos Sleep. Tonight we stand beneath a sky so crowded with stars that it almost feels alive. A vast silver river stretching from horizon to horizon. You tilt your head upward and imagine every tiny point of light hanging there, not as a distant decoration, but as a real sun burning somewhere in the darkness. Some are larger than your own sun. Some have planets circling them. Some may have watched civilizations rise and vanish before Earth even learned to grow forests. And tonight, you set out to answer a deceptively simple question. How big is our galaxy? At first, the answer sounds easy. Surely astronomers can just measure it with a really large ruler. Unfortunately, the universe never cooperates with such reasonable suggestions. Instead, measuring a galaxy is rather like trying to estimate the size of an entire continent while standing in the middle of a forest during a foggy night. You probably won't survive this journey if you attempt it on foot. Not because anything dangerous happens, but because crossing the Milky Way would take far longer than the remaining lifespan of humanity, Earth, and possibly several of your future alarm clocks. So before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And while you're here, leave a comment telling me your location and local time. It's always fascinating to see where in the world fellow night travelers are listening from. Now, dim the lights. Maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You begin standing on Earth, a small rocky planet circling an ordinary star. Nothing about your immediate surroundings suggests that you live inside one of the largest structures ever known to human beings. For most of human history, people didn't even realize the Milky Way was a galaxy. Ancient civilizations saw the glowing band overhead and invented stories to explain it. The ancient Greeks imagined it as spilled milk from the goddess Hera. Many cultures described it as a heavenly road, a river, or a pathway for spirits. One mainstream historical fact is that the philosopher Democritus, more than 2,000 years ago, suggested that the Milky Way might consist of countless distant stars blended together. It was a remarkably accurate idea, especially considering he lacked both a telescope and modern caffeine. When you look upward tonight, you are seeing the same glowing band that inspired those ancient observers. Yet the true scale remained hidden. In the early 17th century, a curious man named Galileo Galilei pointed a telescope toward the Milky Way and discovered that its pale glow was made from enormous numbers of individual stars. Suddenly, the universe became larger, much larger. Imagine standing on a beach. From far away, the shoreline looks smooth and continuous. Walk closer, and you discover millions of separate grains of sand. Galileo's telescope performed a similar trick for the sky. As you drift through this thought experiment, leaving Earth behind, the planet shrinks beneath you. The moon passes, then the planets, then the outer edge of the solar system. Even here, you have barely started. The nearest star beyond the sun is over 4 light years away. A light year, despite the confusing name, is a distance rather than a measure of time. It represents how far light travels in 1 year. Light is absurdly fast. It circles Earth about 7.5 times every second. And yet even light needs more than 4 years to reach the nearest stellar neighbor. You begin to appreciate the challenge. The stars overhead may seem crowded, but space is mostly emptiness. An almost unreasonable amount of emptiness. If the sun were reduced to the size of an orange, Earth would be a tiny grain several meters away. The nearest star would still be hundreds of kilometers distant. Space apparently attended a seminar titled Maximum Personal Space. As your journey continues, more stars emerge around you. You start seeing the local stellar neighborhood, a tiny region within the Milky Way. Nearby suns drift through darkness like lanterns floating across a black ocean. Some stars travel alone, others move in pairs, some possess planets, others have none. Astronomers estimate that the Milky Way contains hundreds of billions of stars. The exact number remains uncertain because counting them individually would be somewhat inconvenient. Imagine trying to count every grain of sand on a continent while riding a bicycle during a snowstorm. The galaxy refuses easy arithmetic. Historians still argue whether some ancient records accurately described the structure of the Milky Way or merely reflected mythological interpretations. The debate continues because evidence from antiquity often leaves room for multiple interpretations. As you move farther from Earth, another fascinating detail emerges. The Milky Way is not a random collection of stars. It has structure, organization. Like a gigantic city viewed from above, its stars occupy enormous spiral arms that curve around a central core. These arms contain gas clouds, newborn stars, and stellar nurseries where future suns are taking shape. A quirky tidbit appears here. Some indigenous traditions around the world interpreted the Milky Way as an actual pathway used by animals, spirits, or ancestors. Though these stories were mythological, they often described the galaxy as a road crossing the sky, a surprisingly fitting image for the sprawling stellar lanes astronomers study today. You continue drifting outward. The sun now becomes just another star among many. Nothing about it appears particularly special. And that realization carries a strange comfort. Humanity often imagines itself standing at the center of things, the center of history, the center of importance, the center of attention. The galaxy politely disagrees. Our sun occupies a fairly ordinary location in a fairly ordinary region of a fairly ordinary galaxy. Yet somehow, that ordinary star gave rise to oceans, forests, music, pizza, and whatever inspired someone to invent glow-in-the-dark garden gnomes. The universe works with unexpected ingredients. Ahead lies the greater Milky Way itself. You can sense its scale before you fully understand it. A faint stellar haze stretches in every direction. Clusters of stars shimmer like distant islands. Dark clouds drift across glowing backgrounds. Immense distances separate everything. And yet this entire realm remains only your cosmic neighborhood. You have not crossed the galaxy. You have not reached its center. You have not even measured its width. You are merely taking your first steps into a structure so vast that light itself requires roughly 100,000 years to travel from one side to the other. For now, you float quietly among nearby stars, letting that number settle into your thoughts like dust descending through still air. The true journey across the Milky Way is only beginning. You linger for a moment among the nearby stars, letting the enormity of the Milky Way settle into your imagination. 100,000 light years. It is a number so large that your brain immediately begins filing a complaint. Human beings evolved to estimate the distance to a tree, a river, perhaps an annoyed mammoth. We did not evolve to comfortably picture a structure so vast that even light, the fastest thing known in nature, spends 100,000 years crossing it. Yet that is exactly where your journey now leads. You continue drifting outward from the sun's neighborhood, climbing higher above the local stars. The galaxy slowly reveals its shape. At first it resembles a misty cloud, then a glowing wheel, then something even grander, a spiral Long curved arms wind around a brilliant central bulge. Between those arms lie darker regions filled with thinner populations of stars. Vast clouds of gas drift through the disk, serving as the raw material for future generations of suns. From a distance, the Milky Way begins to resemble a gigantic celestial hurricane frozen in time. Except this hurricane contains hundreds of billions of stars. And fortunately, much less rain. The realization strikes you that nearly every visible star belongs to this single galaxy. Everything familiar in the night sky is part of one immense system. The constellations, the bright stars of winter, the glowing summer Milky Way, the distant stellar clouds. They all reside within this enormous galactic city. One mainstream historical fact comes from the early 20th century, when astronomers were still debating whether the Milky Way represented the entire universe or merely one galaxy among many. The famous 1920 Great Debate between Harlow Shapley and Heber Curtis helped shape modern understanding of our place in the cosmos. At the time, nobody fully understood how vast reality truly was. You can hardly blame them. Even today, the scale remains difficult to grasp. Imagine shrinking the Milky Way until it fits across North America. In that model, the solar system would be microscopic, not tiny. Not small, microscopic. You would need powerful magnification just to locate it. Earth itself would effectively vanish. The entire history of humanity would disappear into dimensions too small to see. This is where the galaxy begins to feel less like a collection of stars and more like an environment, a continent of suns, an ocean of light, a wilderness beyond ordinary comprehension. As you travel farther, you notice that stars are not distributed evenly. Some regions glow densely, others appear sparse. The spiral arms contain many younger stars because gas clouds there continually create new stellar populations. Massive blue stars shine intensely in these regions. Their lifespans are relatively short. Astronomically speaking, they are the cosmic equivalent of someone spending their entire paycheck on sports cars and fireworks. Bright, exciting, not especially long-term. Meanwhile, smaller red stars quietly endure for billions or even trillions of years. Patience, it turns out, pays off in astrophysics. The spiral structure itself remains a fascinating puzzle. Astronomers understand much about how these arms form, yet some details remain uncertain. Historians still argue whether early observations correctly identified specific spiral features before modern radio astronomy confirmed their existence. As you continue your flight, immense dark lanes become visible. These are giant clouds of dust and gas. They stretch for hundreds of light years. From Earth, they appear as dark gaps cutting across the Milky Way's glowing band. But from your new vantage point, you see their true nature. They are not holes, they are curtains. Behind them lie countless hidden stars. It is a little like mistaking a cloud for empty sky. The galaxy contains far more than the eye initially reveals. A quirky tidbit emerges from astronomical history. In the 18th century, some observers nicknamed certain dark regions of the Milky Way coal sacks because they resembled black patches against the brighter star fields. One famous example, known as the Coal Sack Nebula, remains visible from the southern hemisphere today. The name sounds surprisingly industrial for something drifting peacefully through interstellar space. You push onward. Thousands of light years pass beneath you, then tens of thousands. The scale becomes increasingly difficult to visualize. Suppose you could board a spacecraft traveling at the speed of the fastest human-made probes. Crossing the Milky Way would require millions of years. Entire species could evolve and disappear during the trip. Mountain ranges could rise and erode, languages could emerge and vanish, civilizations could become legends. And you still would not have reached the other side. The galaxy possesses a diameter of roughly 100 light-years, though estimates vary somewhat depending on how one defines its outer boundaries. Some measurements suggest even larger dimensions. This uncertainty arises because galaxies do not end abruptly. There is no giant cosmic fence marked Milky Way ends here. Instead, stellar density gradually decreases. The galaxy fades into surrounding space. Its borders are soft, almost ghost-like. As you look across the disk, the central regions shine brilliantly. The core appears swollen and luminous. Billions upon billions of stars crowd together there. The density increases dramatically compared with the solar system's relatively peaceful neighborhood. You can already sense that future stages of your journey will lead toward those crowded inner regions. But not yet. For now, your task is simply to appreciate the width, the sheer breadth of the structure surrounding you. Imagine standing at one shoreline of an ocean so large that light itself requires 100 millennia to cross it. Then remember that this ocean consists not of water but of stars, hundreds of billions of them, each potentially hosting planets, each carrying its own story, each moving through the galaxy on paths lasting hundreds of millions of years. The Milky Way now stretches beneath you like a luminous continent suspended in darkness. Its spiral arms curl gracefully outward. Its central bulge glows like a distant city. Its far edge remains almost impossibly remote, and somewhere within that vast expanse, tucked into a modest spiral arm, circles a tiny planet where a sleepy listener is contemplating just how enormous home really is. The answer, you realize, is larger than almost any intuition can comfortably contain. Yet you have only begun exploring it. Ahead lies the sun's neighborhood itself, where the galaxy's immensity becomes personal. And there, among nearby stars, the distances grow no less astonishing. You gaze across the immense width of the Milky Way and gradually allow your attention to return toward a much smaller region. Not small by ordinary standards, of course. Nothing in astronomy is ever truly small. But compared with a galaxy 100,000 light-years wide, your local neighborhood is practically a cozy village. Somewhere within one of the Milky Way's spiral arms drifts the sun, carrying Earth and the rest of the solar system along on a journey that began billions of years ago. You begin descending back toward this familiar region. Stars that once appeared as anonymous points of light now acquire identities. Each becomes a destination, a neighbor, a place. The nearest stellar system is Alpha Centauri system, located just over 4 light-years away. That distance sounds manageable until you remember what a light-year actually means. Light travels about 300 zooson kilometers every second. In the time it takes you to blink, a beam of light could circle Earth several times. Yet even moving at that astonishing speed, it requires more than 4 years to reach Alpha Centauri. Your nearest stellar neighbor is not next door. It is across an almost unimaginable gulf. One mainstream historical fact comes from 1838, when Friedrich Bessel successfully measured the distance to a star using stellar parallax. For the first time, humanity possessed direct evidence of the vast separations between stars. The result surprised many people. Space was far larger than previously imagined. You float among nearby stars and begin noticing how empty the region truly is. Science fiction often portrays galaxies as crowded places where ships weave constantly between stars, reality is much quieter, much emptier, much less likely to result in awkward interstellar traffic jams. If the Sun were the size of a marble, the nearest star would still be hundreds of kilometers away. Most of the galaxy consists of space between things, enormous stretches of almost perfect emptiness. You drift past red dwarfs, the most common stars in the Milky Way. These faint little suns burn fuel so slowly that many will outlive the current age of the universe. Some could continue shining for trillions of years, while massive stars blaze brilliantly and die young. Red dwarfs seem content to settle in for the longest shift imaginable. Cosmic endurance champions. The universe's equivalent of that one co-worker who never appears to take a vacation. As you travel farther, you encounter stellar groups and associations. Many stars are born together inside giant molecular clouds. Over time, gravity gradually scatters these siblings across the galaxy. The Sun likely formed among thousands of neighboring stars about 4.6 billion years ago. Today, those stellar siblings have dispersed so thoroughly that identifying them remains difficult. Some astronomers continue searching for long-lost relatives of our Sun. It is essentially a galactic family reunion conducted across thousands of light years. Name tags would help. You pass through regions filled with interstellar gas. The density is astonishingly low. Even the richest clouds contain far less matter than the best vacuum chambers humans can build on Earth. Yet because these clouds span enormous distances, they contain enough material to create entire generations of stars. Tiny particles accumulate. Gravity takes over. New suns ignite. The cycle begins again. A quirky tidbit emerges from the history of astronomy. Some 19th century observers believed certain nebulous patches represented starless holes in the heavens rather than clouds of dust. Only later did improved observations reveal that these dark areas often concealed vast quantities of material, blocking light from more distant stars. The galaxy was literally hiding parts of itself. You continue your journey through the Sun's wider neighborhood. Several familiar stars become visible. Some are older than the Sun, others younger. Some host planetary systems, many probably do. Modern observations suggest that planets are extraordinarily common throughout the Milky Way. There may be more planets than stars. Pause for a moment and consider that possibility. Hundreds of billions of stars, perhaps trillions of planets, each orbiting through darkness, each experiencing its own cycles of day and night. Some may be barren, some may possess oceans, some may have skies illuminated by multiple suns, others might remain forever frozen beneath dim red starlight. The sheer number becomes almost hypnotic. Historians still argue whether certain early philosophers truly envisioned countless inhabited worlds, or whether later interpretations projected modern ideas onto ancient texts. The debate remains lively because surviving writings often leave room for multiple readings. You move through the stellar suburb occupied by the Sun. Astronomers call part of this region the local bubble, a vast cavity in interstellar gas extending hundreds of light years. The solar system currently resides within this relatively sparse environment. Evidence suggests ancient supernova explosions may have helped create it. Long ago, massive stars lived, exploded, and reshaped the surrounding region. Their influence persists even now. The galaxy remembers. Stars die. New stars form, gas flows, structures evolve. Nothing remains perfectly still. Even your own solar system races through space at tremendous speed. You do not feel this motion because everything around you shares it. Yet at this very moment, Earth hurtles around the Sun. The Sun orbits the Milky Way. The galaxy itself moves through the wider cosmos. The universe is a dance performed on scales so large they escape everyday perception. You begin to sense something profound about the Milky Way. Its size is not merely a measurement, it is an experience. Distances shape everything. Communication, travel, exploration, even light, requires years to cross local neighborhoods and millennia to traverse major portions of the galaxy. The stars seem close because the night sky compresses depth into a flat canvas. Reality is different. Reality possesses layers extending far beyond ordinary intuition. Ahead, the spiral arms become more apparent. These gigantic stellar highways curve through the galaxy, guiding the next stage of your journey. You have explored your local suburb. Now you will venture onto the great galactic roads themselves, where stars migrate, clusters disperse, and the Milky Way reveals the dynamic structure hidden beneath its serene appearance. For now, you drift quietly among neighboring suns, surrounded by distances so vast that even the nearest stars remain lonely islands in a cosmic sea. And somewhere behind you, almost lost among billions of others, shines the small yellow star humanity calls home. You continue outward from the sun's neighborhood, leaving behind the familiar stellar suburbs and entering the grand architecture of the Milky Way itself. From here, the galaxy resembles less a collection of stars and more a living system. Gigantic spiral arms sweep around the galactic center like luminous rivers. Each arm stretches for tens of thousands of light years. Each contains countless stars, clouds of gas, and regions where entirely new suns are being born. These are the great highways of the galaxy. Although, unlike human highways, they contain significantly fewer traffic lights and substantially more nuclear fusion. You drift toward one of these vast structures. The solar system currently resides in a smaller feature known as the Orion Arm, sometimes called the Orion Spur. It sits between two larger spiral arms, making our location something like a suburban side street nestled between major galactic avenues. Not the center of attention, not especially glamorous, but remarkably peaceful. One mainstream historical fact is that astronomers spent much of the 20th century trying to map the Milky Way's spiral structure. Because we live inside the galaxy, determining its overall shape proved surprisingly difficult. It was rather like attempting to draw a map of an entire forest while standing among the trees. Radio astronomy eventually helped solve much of the puzzle. Unlike visible light, radio waves can pass through many of the dust clouds that block our view. Suddenly, hidden portions of the galaxy became visible. The Milky Way slowly revealed its secrets. You glide along the Orion Arm. Stars pass below like scattered lanterns. Some regions appear calm. Others glow with active star formation. Massive clouds collapse under gravity. New stars ignite. Planetary systems begin forming. Entire future histories quietly take shape. What feels static from Earth is actually in constant motion. The galaxy is not frozen. It flows. Every star you see is traveling. The Sun itself moves around the galactic center at roughly 220 kilometers per second. That sounds astonishingly fast. And it is. Yet the Milky Way is so enormous that a single orbit still takes about 225 million years. To put that into perspective, the last time the solar system occupied its current galactic position, dinosaurs had not yet appeared. The continents looked different, the oceans looked different. Nearly everything familiar today belonged to an unimaginably distant future. This journey around the galaxy, is sometimes called a galactic year. You have completed only about 20 galactic years since Earth formed. Not 20 million, not 20,000, just 20. Suddenly your annual birthday seems far less impressive. You continue deeper into the spiral structure. The arms are not rigid objects. This surprises many people. Stars move into and out of them over time. The arms behave more like traffic patterns than permanent structures. Imagine a slow-moving crowd, forming temporary clusters on a busy street. The individual people move, yet the pattern remains. The Milky Way's spiral arms operate in a somewhat similar way. Gravity orchestrates that. Stars participate, the pattern persists. A quirky tidbit emerges from astronomical history. Some researchers once proposed that spiral arms might resemble giant shock waves, moving through the galactic disk, compressing gas and triggering star formation as they pass. Although modern models are more sophisticated, the image remains wonderfully dramatic. The galaxy essentially creating waves across tens of thousands of light years. Not bad for something that appears motionless in photographs. You pass enormous nebulae glowing faintly in the darkness. These clouds stretch across distances difficult to comprehend. Some span dozens or hundreds of light years. Inside them, gravity patiently gathers matter into future stars. In many ways, these regions are galactic nurseries. The future of the Milky Way is being assembled molecule by molecule. Some newborn stars emerge surrounded by disks of dust. Within those disks, planets may eventually form, perhaps rocky worlds, perhaps gas giants, perhaps places where future civilizations will one day gaze upward and wonder how large their galaxy might be. The thought creates a pleasant sense of continuity. Questions echo across the cosmos. As you travel farther, you notice that the spiral arms are not evenly populated. Some areas blaze with brilliant young stars, others contain older populations. The brightest stars often dominate astronomical photographs, but they are relatively rare. Most stars in the galaxy are smaller and dimmer, quiet cosmic citizens going about their business for billions of years. Historians still argue whether certain early attempts to map the Milky Way overestimated or underestimated the influence of dust clouds. Before astronomers fully understood how interstellar dust obscured light, many measurements produced misleading impressions of galactic structure. The galaxy was playing hide and seek, and dust was winning. You continue along the stellar highway. The density gradually increases. The central regions ahead glow more brightly. The galactic core remains distant, yet increasingly difficult to ignore. It shines like a city seen across an enormous plain. Billions of stars crowd together there. The environment becomes more energetic, more active, more extreme. For now, though, you remain within the spiral arms, watching their elegant curves sweep through space. The Milky Way no longer feels like a random scattering of stars. It possesses shape, order, rhythm. Its arms guide the movement of gas and stars. Its gravity binds everything together. Its structure stretches across distances so vast that light itself spends tens of thousands of years crossing individual portions. You drift quietly through this immense architecture, carried along pathways that have existed for billions of years. Behind you lies the sun's calm neighborhood. Ahead waits the crowded heart of the galaxy. And with every passing light year, the glow at the center grows brighter, inviting you toward one of the most extraordinary regions in the entire Milky Way. There, among unimaginable concentrations of stars, you will discover what happens when a galaxy gathers much of its brilliance into a single luminous core. You continue along the spiral highways of the Milky Way, gradually leaving behind the relatively calm regions where the sun resides. Ahead, the galaxy grows brighter, not suddenly, not dramatically, but steadily, like approaching a distant city at night. The stars become more numerous. The darkness between them begins to shrink, and far in the distance, the central bulge of the Milky Way dominates the horizon. For most of human history, nobody knew what waited there. The galactic center remained hidden behind enormous clouds of dust and gas. The visible light struggled to penetrate the crowded inner regions. Astronomers could see the glow. They could suspect its importance, but the details remained frustratingly concealed. The heart of the galaxy guarded its secrets carefully. You move inward across thousands of light years. The stellar population gradually changes. Young blue stars become less dominant. Older stars appear more frequently. The density increases. Every direction contains more light, more suns, more ancient history. One mainstream historical fact is that astronomers spent much of the 20th century using infrared and radio observations to peer through the dust, obscuring the galactic center. These technologies gradually revealed structures invisible to ordinary telescopes and transformed humanity's understanding of the Milky Way's inner regions. Without them, the core would still resemble a mystery wrapped inside cosmic fog. You continue approaching. The scale becomes extraordinary. In the sun's neighborhood, nearby stars are separated by several light years on average. Near the galactic center, stars crowd much closer together. The sky from a planet located there would look astonishing. Night might never become truly dark. Thousands upon thousands of bright stars could dominate the heavens. Constellations would be almost impossible to recognize because the sky would be overflowing with light. Astronomy textbooks would need significantly larger pages. As you move deeper inward, enormous star clouds surround you. Many are ancient. Some formed billions of years ago, when the galaxy itself was still relatively young. These stars preserve clues about the Milky Way's earliest history. They are cosmic elders, silent witnesses to epochs long before Earth existed. You pass through regions where gravity exerts a stronger influence. Massive star clusters drift nearby. Gas clouds twist into complex shapes. The environment feels busier, more energetic, more alive. The galaxy's heart is not merely brighter. It is more crowded in almost every sense. A quirky tidbit appears from the history of galactic research. For decades, some astronomers humorously referred to the challenge of studying the galactic center as trying to observe downtown through a dense fog while standing on the outskirts of a continent. The comparison was not entirely inaccurate. Dust obscured so much detail that researchers often had to infer what might exist beyond it. Sometimes they were right. Sometimes the galaxy surprised them. And the galaxy enjoys surprises. You continue onward. The central bulge now fills a significant portion of your view. Unlike the thin spiral disk, this region rises above and below the galactic plane. It contains immense numbers of stars packed into a roughly spherical structure. From a distance, it resembles a glowing lantern embedded within the Milky Way's center. Astronomers estimate that billions of stars occupy this region alone. The sheer quantity becomes difficult to visualize. Imagine every grain of sand on a beach becoming a star. Then imagine many beaches. Then imagine somebody continuously adding more beaches while you are counting. That approximation still struggles to capture the scale. Historians still argue whether certain early observations of the galactic bulge accurately reflected its true shape. As better instruments became available, astronomers discovered that the inner Milky Way possesses a more complex structure than many earlier models suggested. Reality, as usual, refused to remain simple. You drift through the outer portions of the bulge. Stars surround you in every direction. The galaxy feels less like a flat disk and more like a vast three-dimensional metropolis. Light pours across space. Ancient suns glow orange and red. Some stellar populations here are among the oldest major components of the Milky Way. Their ages stretch back close to the galaxy's formative years. These stars have completed many journeys around the galactic center, far more than the Sun. They have watched the Milky Way evolve for billions upon billions of years. If stars could become historians, this region would contain an entire library. As you continue inward, another realization emerges. The center of the galaxy is not simply crowded, it is dynamic. Stars orbit rapidly. Gravity shapes every motion. Massive structures influence their surroundings across enormous distances. The deeper you travel, the more apparent this becomes. Something significant lies ahead. Something powerful enough to affect the motions of stars throughout the inner galaxy. You cannot see it yet, at least not clearly, but its presence is unmistakable. The stars themselves reveal it. Their orbits curve and accelerate. Their motions hint at an invisible ruler occupying the heart of the Milky Way, a hidden giant, a gravitational monarch. A cosmic heavyweight operating quietly behind the scenes. You drift closer. The density rises further. Bright stars fill your view. Clusters shimmer against the darkness. Gas clouds swirl through the crowded environment. Everywhere, gravity leaves its signature. The center feels alive with motion, alive with history, alive with scale. And yet the most remarkable object in the entire region remains concealed. Soon you will reach the very heart of the galaxy. There, buried among millions of surrounding stars, waits an object so extreme that not even light can escape its grasp. A supermassive black hole, the hidden giant around which much of the Milky Way ultimately revolves. For now, though, you simply float at the threshold of the galactic core. Watching billions of stars glow together in the darkness, the journey inward is nearly complete, and the greatest mystery of the Milky Way lies directly ahead. You drift deeper into the crowded heart of the Milky Way, where the glow of countless stars surrounds you from every direction. The galaxy's central bulge stretches far behind. The spiral arms lie in the distance. And now, hidden among all this brilliance, you approach the object that dominates the very center of our galaxy. At first, you see nothing unusual. That may sound disappointing. After all, you have traveled tens of thousands of light years to visit one of the most extraordinary objects in existence. Surely there should be flashing lights, dramatic warning signs, perhaps a giant cosmic banner reading, "Danger, physics becomes weird ahead." Instead, the center appears deceptively normal. Stars orbit. Gas drifts, light shines, yet something powerful lurks within, something invisible. You move closer. The surrounding stars reveal the truth. Their paths curve sharply around an unseen point. Some race through space at astonishing speeds. Others complete tight orbits that would be impossible unless an enormous mass occupied the center. Astronomers spent decades studying these stellar motions. The stars became witnesses. Their movements testified to the existence of a hidden giant. One mainstream historical fact is that observations by astronomers, including Andrea Ghez and Reinhard Genzel, provided compelling evidence that a supermassive black hole resides at the center of the Milky Way. Their work eventually earned recognition through the 2020 Nobel Prize in Physics. The object is known as Sagittarius A. Astronomers usually pronounce it Sagittarius A star. Despite its relatively modest-sounding name, it is anything but modest. Its mass equals roughly 4 million suns. 4 million, compressed into a region smaller than the orbit of some planets. The numbers quickly become surreal. You continue your approach. Still, you do not actually see the black hole itself. That is because black holes do not emit visible light. Their gravity is so intense that once light crosses a certain boundary, known as the event horizon, escape becomes impossible. Light enters, light stays. The universe provides no refunds. Yet the black hole's presence remains unmistakable. Nearby gas heats to enormous temperatures. Stars accelerate around it. Gravity shapes everything in the region. It is like standing beside a waterfall hidden in thick fog. You may not see the water directly, but every surrounding clue reveals its existence. A quirky tidbit emerges from black hole history. For years, some people imagined black holes as giant cosmic vacuum cleaners wandering the universe and swallowing everything nearby. Reality is less dramatic. If the sun magically became a black hole while keeping the same mass, Earth would continue orbiting almost exactly as before. Life would have other problems, admittedly, very serious problems. But orbital mechanics would remain surprisingly familiar. Gravity depends on mass, not on whether that mass happens to be a star or a black hole. You float near the galactic center and watch stars complete astonishing journeys. Some orbit Sagittarius A in mere decades. One famous star, often called S2, has been observed completing a full orbit around the black hole. Its motion provided crucial evidence about the immense mass concentrated at the center. The measurements were so precise that astronomers could test aspects of Einstein's theories in this extreme environment. And Einstein continues to perform remarkably well for someone who passed away in 1955. As you linger here, another realization emerges. The black hole itself is tiny compared with the galaxy, enormously massive, incredibly influential, yet physically tiny relative to the Milky Way's full scale. This often surprises people. The Milky Way spans roughly 100,000 light-years. Sagittarius A occupies only a minuscule fraction of that distance. The galaxy is not dominated by the black hole's size. It is dominated by its gravity. Those are very different things. Historians still argue whether early theoretical discussions about dark stars in the 18th century should be considered intellectual ancestors of modern black hole concepts. The connection is intriguing, though scholars continue debating how directly those ideas relate. The history of science, much like the galaxy itself, contains winding paths. You continue observing the region. Stars pass through complex gravitational environments. Gas clouds collide and compress. Radiation emerges from energetic processes near the center. The galactic core is not merely crowded, it is active, dynamic, restless. Compared with the solar system's relatively quiet neighborhood, this place feels almost bustling. If the outer galaxy resembles a rural countryside, the core resembles a luminous downtown district operating around the clock. Only with fewer coffee shops and considerably more relativistic physics. You begin pulling back slightly. As your distance increases, the central black hole becomes part of a larger picture. The stars surrounding it blend together. The galactic bulge regains prominence. The Milky Way's immense architecture comes back into view. And another question emerges: how thick is this enormous structure? From Earth, the galaxy often appears as a flat band crossing the sky, yet appearances can be misleading. The Milky Way possesses depth. Height, layers extending far above and below the familiar disk. Soon you will leave the crowded center behind and rise beyond the galactic plane itself. There, looking down upon the galaxy from above, you will discover dimensions that remain invisible to most observers on Earth. For now, though, you rest quietly near the heart of the Milky Way, watching stars dance around an invisible giant. A giant that weighs millions of suns, a giant hidden within a galaxy containing hundreds of billions more. And somehow, in a universe famous for excess, that remarkable black hole is merely one chapter in a much larger story. You slowly leave the crowded core behind. The brilliant concentration of stars begins to shrink beneath you as you rise away from the galactic plane. At first, the change is subtle. The Milky Way still appears as an enormous city of light stretching across space. But as your altitude increases, a new perspective emerges. The galaxy that looked like a glowing band from Earth begins revealing its true shape. It is not infinitely thin, not even close. The Milky Way has height diff, layers extending far above and below its familiar disk. From inside the galaxy, this dimension is easy to overlook. It is a bit like living inside a sheet of paper and trying to understand thickness. The concept exists, but appreciating it fully requires stepping outside. So you continue upward. Thousands of light years pass beneath you. The spiral arms flatten into graceful curves. The central bulge becomes more obvious. The entire galaxy starts resembling a gigantic cosmic pancake. A very thick pancake, a pancake containing hundreds of billions of stars, and probably not approved by any nutritionist in the universe. One mainstream historical fact is that astronomers gradually realized during the 20th century that the Milky Way's stellar populations occupy different vertical regions. Younger stars tend to remain closer to the galactic plane, while older populations can be found much farther above and below it. The galaxy, it turns out, possesses layers. Different generations of stars inhabit different neighborhoods. Some remain close to the bustling disk. Others wander far from it. You continue climbing. Now the Milky Way stretches beneath you like a glowing island. Its diameter remains immense, roughly 100,000 light-years across. Its thickness, however, is much smaller. The thin stellar disk containing most visible stars measures only a few thousand light-years thick. Even that reduced number sounds enormous by ordinary standards. And it is. Yet compared with the galaxy's width, the disk appears surprisingly slender. Nature seems fond of gigantic structures that are thinner than expected. Saturn's rings demonstrate the same tendency. So does pizza dough, although admittedly on different scales. As you look downward, intricate patterns emerge. The spiral arms weave through the disk. Dark dust lanes cut across bright stellar regions. Gas clouds drift through interstellar space. The galaxy resembles a living ecosystem. Everywhere, stars are forming, evolving and dying. The Milky Way never truly rests. A quirky tidbit appears from astronomical observations. Some stars travel so far above the galactic plane that they seem almost detached from the familiar disk. These stellar wanderers follow unusual orbits that carry them tens of thousands of light years from the galaxy's central layer. The Milky Way apparently encourages exploration, at least for stars. Human airline budgets may vary. You continue rising higher. The familiar disk grows thinner, more compressed, more clearly defined. From this perspective, the galaxy's structure becomes easier to understand. The central bulge swells upward, the spiral arms spread outward, the disk extends like a luminous wheel suspended in darkness. Yet another fascinating detail becomes apparent. Not all stars move in the same neat pattern. Some populations follow relatively orderly orbits around the galactic center. Others travel on paths tilted at different angles. The galaxy contains multiple stellar communities, each preserving clues about ancient events in Milky Way history. Some of these stars may have originated in smaller galaxies that merged with our own billions of years ago. The Milky Way has grown through cosmic encounters. Like many large galaxies, it accumulated material over time. Historians still argue whether certain stellar streams represent the remnants of ancient galactic mergers or arose through other dynamical processes. New observations continue refining the picture, and debates remain active. The galaxy keeps parts of its autobiography scattered among the stars. You drift farther above the disk. The view becomes increasingly breathtaking. The spiral structure now stands out clearly. Bright arms curl around the central bulge. Dark regions separate luminous lanes. Massive clouds trace invisible gravitational patterns. From Earth, the Milky Way appears as a narrow river of light. From here, it resembles an entire continent. A continent larger than almost anything the human mind comfortably handles. You begin noticing something else. The stars do not abruptly stop at the disk's edge, even above the main plane. Scattered stellar populations remain visible. The galaxy extends farther than the eye initially expects. Its boundaries are less tidy than textbook illustrations often suggest. Reality rarely follows clean diagrams. Astronomers create beautiful models. The universe then responds by adding extra complications. As your ascent continues, the density of stars decreases. Darkness becomes more prominent. The galaxy's glow remains magnificent, but individual stars grow more isolated. The disk now appears suspended within a much larger environment. An environment not immediately obvious from Earth. An environment that contains ancient stars, mysterious dark matter, and structures extending far beyond the familiar spiral arms. You are approaching the realm known as the halo, a vast region surrounding the Milky Way, a region so large that many people barely realize it exists. From here, the galaxy no longer resembles a simple disk. It becomes part of something larger, something more diffuse, more mysterious, more difficult to map. The familiar stellar city occupies only the inner portion of an enormous galactic domain. And beyond the glowing disk, hidden in darkness, and populated by ancient relics of cosmic history, waits the next stage of your journey. You take one last look downward. The Milky Way stretches beneath you in elegant silence. Its width remains staggering, its thickness now understandable, its structure clearer than ever before. And beyond its visible layers, extending into the darkness, the halo beckons, a quiet frontier surrounding the galaxy like an invisible kingdom. You continue rising above the Milky Way's disk until the familiar spiral structure begins to look almost delicate. Below you, the galaxy glows like a vast wheel of starlight. Its spiral arms curl gracefully around the central bulge. Its bright disk dominates the scene. Yet now you notice something surprising. The galaxy does not end where the disk ends. Far beyond the spiral arms, beyond the regions most people imagine when they picture the Milky Way, lies a much larger and stranger realm, the halo, a vast spherical region surrounding the galaxy. A region so enormous that it makes even the already gigantic disk seem like only part of the story. You drift farther into this quiet territory. Immediately, the environment feels different. Stars become much rarer. The bright lanes of the disk fade into the distance. Darkness expands. The silence seems deeper. If the galactic disk resembles a bustling city, the halo feels like a remote wilderness stretching beyond the horizon. One mainstream historical fact is that astronomers gradually discovered during the 20th century that many ancient star clusters and stellar populations occupied regions far outside the visible disk. These observations revealed that the Milky Way extended much farther than earlier models had suggested. The galaxy was larger than expected, then larger still, and eventually much larger than almost anyone had imagined. You continue outward. Scattered stars drift through the darkness. Many are extraordinarily old. Some formed more than 12 billion years ago, making them among the oldest surviving stars in the Milky Way. These ancient objects were already shining when the universe itself was comparatively young. While Earth formed only about 4.6 billion years ago, these stars had already existed for billions of years. They are veterans of cosmic history. The halo preserves them like a museum preserving ancient artifacts. You look back toward the disk. The Milky Way now appears suspended within a much larger structure, a structure not entirely visible because the halo contains something even more mysterious than stars. Dark matter. You cannot see it. No telescope can photograph it directly. Yet evidence suggests that enormous quantities surround the galaxy. Without dark matter, the motions of stars within the Milky Way become difficult to explain. Galaxies appear to contain far more mass than visible matter alone can account for. Something unseen contributes gravity, something vast, something still poorly understood. A quirky tidbit emerges from the history of dark matter research. When astronomers first realized that galaxies seemed to contain missing mass, some scientists jokingly referred to the problem as if the universe had misplaced a significant portion of its inventory. Decades later, the missing mass problem remains one of the greatest mysteries in modern astronomy. The universe apparently continues losing paperwork. You drift deeper into the halo. The scale becomes extraordinary. The visible stellar disk spans roughly 100,000 light-years. The dark matter halo may extend several 100,000 light-years from the galactic center. Some estimates suggest even greater distances. The exact boundary remains uncertain because dark matter does not conveniently place signs announcing where it ends. The galaxy fades gradually into surrounding space. Its influence extends far beyond what the eye can see. Historians still argue whether early observational clues pointing toward dark matter were fully appreciated at the time or only recognized in hindsight after later discoveries confirmed their significance. Science often works this way. A puzzle piece appears, nobody recognizes its importance. Years later, it becomes central to the entire picture. You continue floating through the halo. Occasionally, small stellar streams become visible. These elongated ribbons of stars stretch across enormous distances. Many originated from smaller galaxies or star clusters that ventured too close to the Milky Way. Gravity gradually pulled them apart. Their stars now trace delicate arcs through the halo, like cosmic breadcrumbs, evidence of ancient encounters. The Milky Way has not always existed in isolation. Over billions of years, it interacted with smaller neighboring galaxies. Some merged completely, others left behind stellar streams. The halo remembers these events. Its stars preserve records of long-forgotten galactic collisions. You begin to appreciate the halo as a historical archive. The disk reflects ongoing activity, star formation, gas dynamics, spiral structure. The halo, meanwhile, preserves ancient clues. Its oldest stars reveal conditions from the early universe. Its stellar streams record mergers and interactions. Its dark matter influences everything while remaining hidden. The farther you travel, the more mysterious the galaxy becomes. You glance back again. The Milky Way now appears almost fragile. A bright island surrounded by a vast sphere of darkness. The familiar spiral arms occupy only a fraction of the galaxy's total domain. Most people imagine the Milky Way as the glowing band visible from Earth. Yet from here, you realize that much of the galaxy remains invisible. The visible stars are only part of the story. The unseen structures matter too, perhaps even more. As you continue outward, scattered objects begin appearing ahead. These spherical collections of ancient stars. Some of the oldest structures associated with the Milky Way. They drift through the halo like luminous lanterns. Each contains hundreds of thousands of stars, sometimes millions. Each preserves a chapter from the galaxy's earliest history. These are globular clusters, remarkable survivors from the distant past. They have orbited the Milky Way for billions of years. They have witnessed eras beyond human comprehension. And they await your arrival in the next stage of the journey. For now, you float quietly within the enormous halo, surrounded by darkness, ancient stars, and mysteries still unsolved. The Milky Way stretches beneath you. Its visible disk glows softly. Its hidden mass extends far beyond sight. And for the first time, you begin to understand that our galaxy is not merely bigger than it appears. It is vastly, profoundly larger. You drift through the vast darkness of the halo, leaving the bright spiral disk far below. The Milky Way now resembles a luminous island suspended in an ocean of blackness. Its spiral arms glow softly. Its central bulge shines like a distant lantern. And scattered throughout the halo are some of the oldest surviving structures in the galaxy. Ahead, clusters of stars begin to emerge. Not loose groups, not temporary gatherings, but dense, ancient spheres containing hundreds of thousands, sometimes millions, of stars packed into relatively small volumes of space. These are globular clusters, and they are among the oldest residents of the Milky Way. You approach one slowly. From a distance, it resembles a glowing pearl hanging in darkness. As you draw nearer, individual stars become visible. Then thousands, then tens of thousands. The cluster appears almost impossibly crowded. Near its center, stars can be separated by mere fractions of a light year. Compared with the solar system's relatively spacious neighborhood, the environment feels astonishingly dense. The night sky from a planet inside such a cluster would likely be breathtaking. Bright stars could dominate the heavens. Constellations might look entirely different. Darkness itself would become a rare commodity. One mainstream historical fact is that globular clusters have fascinated astronomers for centuries. The famous English astronomer Edmund Halley catalogued several of them in the 17th century, long before scientists understood their true significance. At the time, they appeared as fuzzy patches of light. Only later did powerful telescopes reveal their immense populations of stars. You continue toward the cluster. Its age becomes one of the most remarkable aspects. Many globular clusters formed more than 12 billion years ago. That means they originated relatively soon after the universe itself came into existence. These stars were already ancient when Earth formed, already ancient when the dinosaurs appeared. already ancient when humans first learned to write. The cluster has existed through nearly the entire history of the Milky Way. It is essentially a living fossil, a preserved relic from cosmic antiquity. You float among its stars. Golden suns dominate many regions. These stellar populations differ noticeably from those found in younger parts of the galactic disk. Heavy elements are less abundant. The stars reflect conditions that existed in the early universe. Astronomers study them partly because they provide clues about galactic evolution. Each cluster acts like a time capsule, a preserved snapshot from an earlier epoch. A quirky tidbit emerges from astronomical history. For many years, some globular clusters were nicknamed celestial beehives because observers thought their densely packed stars resembled swarms of glowing insects clustered together in the night sky. The comparison remains oddly charming, though admittedly these bees are separated by astronomical distances and powered by nuclear fusion. You continue deeper into the cluster. The density becomes almost surreal. Stars fill your view in every direction. Many orbit within the cluster's collective gravitational field, tracing paths established billions of years ago. The entire structure moves around the Milky Way, circling the galaxy through the halo. Some globular clusters follow highly elongated orbits. Others travel along different paths. Each possesses its own history, its own journey, its own story. Historians still argue whether certain globular clusters formed alongside the Milky Way itself or originated in smaller galaxies later absorbed by our own. Evidence exists for both possibilities, and ongoing research continues refining the picture. The galaxy's family tree remains wonderfully complicated. You leave the cluster behind and continue through the halo. Several more become visible. Each appears as a brilliant sphere of ancient starlight. Some contain hundreds of thousands of stars. Others exceed 1 million. Together, they form a population distributed throughout the galactic halo. The Milky Way hosts more than 150 known globular clusters. Possibly more remain undiscovered. The galaxy still holds secrets, even in regions astronomers have studied for generations. You glance back toward the disk. The contrast is striking. The spiral arms represent ongoing activity, star formation, gas dynamics. Yes, stellar populations. Globular clusters tell a different story. They speak of survival, of endurance, of structures that have remained intact across unimaginable spans of time. Billions of years pass. The clusters continue orbiting. Empires rise and vanish on Earth. The clusters continue orbiting. Entire species appear and disappear. The clusters continue orbiting. There is something strangely comforting about such persistence. You begin appreciating the Milky Way not merely as a physical structure, but as a historical one. Different regions preserve different chapters. The disk records current events. The halo preserves ancient memories. Globular clusters serve as archival vaults filled with clues from the distant past, and all of it belongs to the same galaxy. The same colossal system stretching across more than 100,000 light-years. The same structure carrying Earth through space at extraordinary speed. You drift farther from the cluster population. The halo grows darker again. The ancient spheres fade into the distance. Ahead lies another realization about scale. The Milky Way is not stationary, neither are its stars, neither is the sun. Everything moves, everything orbits, everything participates in a slow gravitational dance, unfolding over hundreds of millions of years. Soon you will watch the entire galaxy in motion. You will measure a galactic year. You will see stars circling the center across timescales that dwarf human history. And you will discover that even a galaxy as enormous as the Milky Way spends its existence constantly traveling through the darkness. For now, though, you linger among the oldest surviving structures in our galactic home. Ancient clusters glow softly behind you. The halo stretches outward in every direction, and the Milky Way, vast beyond ordinary comprehension, continues its slow journey through the universe. You leave the ancient globular clusters behind and turn your attention back toward the Milky Way itself. From this distant vantage point, the galaxy appears almost serene, a graceful spiral suspended in darkness. Its arms curve elegantly around the central bulge. Its stars shine with quiet confidence. Everything seems calm, everything seems still, but appearances can be wonderfully deceptive. The entire galaxy is moving. Every star, every cloud of gas, every planet, every comet, every grain of dust. Nothing remains fixed. The Milky Way is a gigantic machine of motion. You begin watching the galaxy not as a static object, but as a living system evolving through time. Stars orbit the center, gas flows through spiral arms, clusters drift through the halo. Even the enormous dark matter halo participates in the galaxy's gravitational architecture. Motion is everywhere. One mainstream historical fact is that astronomers spent centuries debating whether the stars themselves moved significantly across the heavens. Precise observations by astronomers such as Edmund Halley eventually demonstrated that certain stars changed position over long periods, proving that the stellar universe was dynamic rather than fixed. The sky was not frozen, it was alive. Human timescales had simply been too short to notice. You watch the Milky Way begin a slow rotation, the stars closest to the center orbit more rapidly. Farther out, motion remains substantial, but follows different patterns influenced by the galaxy's overall mass distribution. The scale of the movement is difficult to comprehend. The Sun travels around the galactic center at roughly 220 kilometers per second. That is fast enough to circle Earth several times in a minute. Yet, because the galaxy is so immense, completing one orbit takes approximately 225 million years. This period is often called a galactic year. You pause and consider that number. 225 million years. The last time the solar system occupied its current position around the Milky Way, the world looked utterly different. Dinosaurs had not yet appeared. The Atlantic Ocean did not exist in its modern form. Mammals remained small and inconspicuous. Human beings were still unimaginably far in the future. A single lap around the galaxy spans epochs. Entire chapters of planetary history fit inside one orbit. Your annual birthday suddenly seems rather modest. A quirky tidbit emerges here. If you could somehow celebrate every galactic year, you would have enjoyed only about 20 birthdays since Earth's formation. 20. That is fewer birthdays than many house cats experience. The Milky Way has a remarkable talent for making everything feel simultaneously important and tiny. You continue watching. Spiral arms sweep around the center, yet they do not rotate like the solid spokes of a wheel. Different regions move at different rates. Stars drift into and out of the arms over time. The pattern persists even while individual stars migrate. It resembles a traffic jam extending across tens of thousands of light years, except nobody is honking, at least as far as we know. The galaxy's motion reveals another mystery. According to ordinary expectations, stars farther from the center should orbit more slowly. Yet observations show that outer regions often move faster than visible matter alone predicts. This discrepancy became one of the major clues leading astronomers toward the concept of dark matter. Something unseen contributes additional gravity. Without it, much of the galaxy's observed motion becomes difficult to explain. The stars themselves exposed the puzzle. Gravity left fingerprints. Astronomers followed the evidence. Historians still argue whether the earliest observational hints of dark matter were fully appreciated when first recorded or only recognized as significant after later theoretical developments. Scientific understanding often grows gradually rather than through sudden revelation. The universe rarely hands out complete instruction manuals. You continue observing the galaxy across accelerated time. Millions of years pass, spiral arms shift, stars change position, massive stars are born and die, new generations emerge, the Milky Way evolves continuously. Even though the changes occur slowly from a human perspective, they become obvious when viewed across cosmic timescales. The galaxy behaves less like a photograph and more like a weather system, dynamic, complex, always changing. You notice stellar streams arcing through the halo. Globular clusters continue their ancient orbits. The central bulge remains crowded and energetic. Sagittarius A sits quietly at the heart of it all, influencing nearby stars through its immense gravity. Every component participates in the dance. Nothing stands apart. The scale remains staggering. The Milky Way contains hundreds of billions of stars. Each follows its own orbit. Each responds to gravity. Each contributes to the galaxy's overall story. Coordinating such a system would challenge even the most ambitious project manager in history. Fortunately, gravity never misses a meeting. You drift farther back. The galaxy now appears smaller. Its rotation becomes easier to appreciate, a luminous whirlpool of stars turning slowly through the darkness. Yet another realization emerges. As vast as the Milky Way seems, it is not alone. Other galaxies surround it. Some are tiny companions, others rival its size. A few are larger still. The Milky Way belongs to a larger community. A cosmic neighborhood extending far beyond the familiar spiral disk. Soon you will meet those neighbors. You will compare their sizes. You will discover where our galaxy fits within the local population. And you will learn that even something 100,000 light-years across occupies only a modest place in the wider universe. For now, though, you watch the Milky Way complete its graceful dance. Stars orbit, clusters drift, dark matter shapes invisible structures, and the entire galaxy continues its journey through time, carrying Earth along on a voyage so vast that humanity has experienced only a tiny fraction of a single galactic year. You continue watching the Milky Way rotate through the darkness, its spiral arms turning so slowly that entire civilizations could rise and disappear before the motion became noticeable from within. The galaxy is immense. But how do astronomers actually know that? How can anyone measure something so large when we live inside it? It is one of the most remarkable detective stories in science. After all, measuring a nearby building is straightforward. You can walk around it, measure its walls, count its floors. Measuring a galaxy is more like trying to determine the size of an entire forest while trapped somewhere among the trees. And not just any forest. A forest 100,000 light-years wide. You begin retracing the methods humans developed to solve this challenge. The story starts with distance. Everything depends on knowing how far away things are. Without reliable distances, the Milky Way remains a confusing collection of lights scattered across the sky. With distances, Structure emerges, pores appear. The galaxy begins revealing its shape. One mainstream historical fact is that astronomers first achieved reliable stellar distance measurements in the 19th century using parallax. As Earth moves around the Sun, nearby stars appear to shift slightly relative to more distant ones. Measuring that tiny shift allows scientists to calculate distance. The method sounds simple. The execution is considerably less forgiving. The apparent shifts are incredibly small. Imagine observing a coin from several kilometers away and trying to detect movement smaller than its thickness. Astronomers somehow managed. Human persistence can be surprisingly stubborn. You watch generations of observers refining these techniques. Better telescopes arrive. More accurate instruments emerge. Distances become increasingly reliable. The local neighborhood of stars gradually takes shape, but measuring nearby stars alone does not reveal the size of the entire Milky Way. A larger approach becomes necessary. Astronomers begin searching for objects that can serve as cosmic mile markers. Certain stars prove particularly useful. Some variable stars brighten and dim in predictable ways. By studying those patterns, researchers can estimate their true brightness. Comparing true brightness with observed brightness reveals distance. Suddenly, astronomers gain access to much larger regions of the galaxy. The map begins expanding. A quirky tidbit emerges from this era. For a time, astronomical distance measurements became so important that some researchers jokingly described variable stars as the universe's official measuring tape. It was not entirely a joke. Those stars genuinely helped humanity determine the scale of the cosmos. You continue following the story. In the early 20th century, astronomers started constructing increasingly sophisticated maps of the Milky Way. One of the most influential figures was Harlow Shapley. By studying globular clusters, he realized that the Sun was not located near the center of the galaxy. This was a major revelation. Many earlier assumptions had placed humanity much closer to the middle. The universe disagreed once again. Shapley's work showed that the Milky Way extended far beyond the solar system. The galaxy possessed a central region located tens of thousands of light years away. Earth occupied an off-center position, a suburban address rather than a downtown apartment. You continue examining how later discoveries refined the picture. Radio astronomy transformed everything. Visible light struggles to penetrate the dense dust clouds scattered throughout the galaxy. Radio waves can often pass through them. Suddenly, astronomers gained access to hidden regions. The Milky Way's spiral structure became clearer. Gas clouds revealed their locations. The galaxy's architecture emerged in unprecedented detail. Historians still argue whether some early galactic maps deserve more credit than they typically receive, given the limited data available at the time. Considering the obstacles involved, many of those pioneering efforts were remarkably successful. Science often advances through imperfect maps that gradually improve. You watch technology continue evolving. Infrared telescopes reveal stars hidden behind dust. Space-based observatories avoid atmospheric interference. Computers process enormous quantities of data. Surveys catalog millions and eventually billions of stars. The map becomes richer, sharper, more complete. Then comes one of the most ambitious projects in astronomical history. The European Space Agency launches the Gaia mission. Its goal is astonishing. Measures the positions and motions of an enormous number of stars with extraordinary precision. The resulting dataset transforms understanding of the Milky Way. Suddenly, astronomers possess an unprecedented three-dimensional view of our galactic home. The forest begins revealing its full extent. You drift through this evolving map. Stars acquire distances, clusters gain locations, streams emerge within the halo. The shape of the galaxy becomes increasingly clear, and yet uncertainties remain. Because galaxies do not possess sharp edges, this creates a subtle challenge. Exactly where does the Milky Way end? Different definitions can produce slightly different answers. The visible stellar disk extends roughly 100,000 light-years across. The dark matter halo extends much farther. The galaxy's influence gradually fades rather than stopping abruptly. Nature apparently dislikes neat boundaries, a recurring theme throughout astronomy. You step back mentally and appreciate the achievement. Human beings evolved on a small rocky world orbiting an ordinary star. Without leaving the solar system, they figured out the approximate size of a galaxy containing hundreds of billions of stars. That accomplishment deserves a moment of admiration. Not bad for a species that occasionally forgets why it walked into a room. The Milky Way now stands before you as a measured object, not perfectly measured, not completely understood, but mapped with remarkable accuracy. Its spiral arms, its central bulge, its halo, its clusters, its dark matter, all woven together into a coherent picture. And now that you know how astronomers measured our galaxy, a new question naturally emerges. How does it compare with others? Is the Milky Way unusually large, unusually small, or simply one galaxy among many? Ahead lie neighboring galaxies waiting to provide perspective. Because sometimes the best way to understand the size of home is to visit the neighbors. You drift away from the Milky Way and allow distance to grow between yourself and your galactic home. The spiral disk gradually shrinks, the central bulge softens into a concentrated glow. The halo becomes difficult to distinguish. For the first time, you see the Milky Way not as a place you inhabit, but as a complete object floating in space. And immediately, a new question appears. How does it compare with other galaxies? After all, a city can feel enormous until you visit a continent. A mountain can seem gigantic until you see an entire mountain range. Scale is often relative. So you continue outward into the cosmic neighborhood surrounding the Milky Way. This region is known as the local group, a small collection of galaxies bound together by gravity. Small here requires a generous astronomical definition. The local group spans millions of light years. Astronomers occasionally use words that would terrify real estate agents. You begin noticing companions around the Milky Way. Some are tiny dwarf galaxies, others are more substantial. Each follows its own path through space. Each contributes to the broader structure of the local group. One mainstream historical fact is that astronomers gradually discovered many dwarf galaxies orbiting the Milky Way throughout the 20th century and beyond. These small companions helped reveal that galaxies often exist within larger gravitational communities rather than in complete isolation. The universe enjoys forming neighborhoods. You approach one of the Milky Way's most famous companions, the Large Magellanic Cloud. From Earth, it appears as a faint patch of light visible in southern skies. From here, it reveals itself as a genuine galaxy, smaller than the Milky Way, yet still containing billions of stars. That is an important lesson. Even small galaxies can be enormous. The Large Magellanic Cloud spans roughly 14,000 light-years across, large enough to dwarf almost every structure humans have ever imagined, small enough to be considered a galactic companion. perspective remains ruthless. Nearby drifts the small Magellanic Cloud, another satellite galaxy, another collection of stars, gas, dust, and dark matter. Together, these companions orbit the Milky Way while interacting gravitationally with it. The relationship resembles a cosmic dance lasting billions of years. Though admittedly with fewer ballroom lessons, you continue exploring. Dozens of smaller dwarf galaxies populate the local group. Some are faint and diffuse, others contain surprisingly rich histories. Many have experienced close encounters with larger galaxies. Some are gradually being disrupted by tidal forces. The Milky Way is not merely surrounded by neighbors, it actively influences them. Gravity shapes the community. A quirky tidbit emerges here. Several dwarf galaxies are so faint that astronomers only discovered them relatively recently, despite their proximity. Some contain very few stars compared with larger galaxies, making them extraordinarily difficult to detect against the background of space. Imagine trying to spot a dim candle beside a stadium floodlight. The challenge is substantial. You continue moving outward until another structure begins dominating the horizon. At first it resembles a distant glowing cloud, then a disk, then a galaxy, a very large galaxy. This is Andromeda Galaxy. Andromeda is the Milky Way's nearest major galactic neighbor. Located roughly 2.5 million light-years away, it appears faintly visible to the unaided eye under dark skies. Think about that for a moment. Human eyes can detect light that left another galaxy millions of years ago. A remarkable capability for equipment that occasionally struggles to locate reading glasses. You compare the two galaxies. Both are spiral galaxies. Both contain hundreds of billions of stars. Both possess dark matter halos. Both dominate the local group. Andromeda may actually be somewhat larger than the Milky Way in certain respects, though estimates continue evolving as measurements improve. Historians still argue whether earlier size estimates for Andromeda and the Milky Way systematically favored one galaxy over the other due to observational limitations. Improved data have refined the comparison, but some uncertainties remain. The cosmic rivalry continues. You drift farther back. Now multiple galaxies become visible simultaneously. The Milky Way, Andromeda, the Magellanic Clouds. Various dwarf companions, together they form a gravitational family, a loose community traveling through space. Suddenly, the Milky Way acquires context. It is not the largest galaxy known. Far from it. Some giant elliptical galaxies exceed it dramatically in size and mass. Nor is it particularly small. It comfortably occupies the category of a major spiral galaxy, large enough to dominate its local surroundings. Modest enough to avoid cosmic celebrity status, a respectable galactic middleweight, perhaps even a heavyweight, depending on which galaxies happen to be standing nearby. You look back toward home. The Milky Way remains magnificent, 100,000 light-years across. Hundreds of billions of stars, ancient clusters, a supermassive black hole, an enormous dark matter halo, yet the existence of neighboring galaxies reveals an important truth. No galaxy exists entirely alone. Every large structure belongs to an even larger environment. The pattern repeats. Stars form galaxies, galaxies form groups, groups form clusters. The hierarchy continues. And among all those neighboring galaxies, one stands out above the rest. Andromeda, because its future is intertwined with our own. At this very moment, the two galaxies are moving toward each other, slowly, relentlessly, across millions of light years. A collision is coming, not tomorrow, not next year, not even remotely soon. But eventually, And when it arrives, the size of the Milky Way will become even greater than it is today. You continue drifting through the local group, watching the Milky Way and Andromeda suspended across millions of light years of darkness. At first glance, they seem perfectly still. Two majestic spiral galaxies separated by an enormous gulf, two islands of stars quietly occupying their own corners of space. Yet beneath that calm appearance, something remarkable is happening. They are moving toward one another. Right now, at this very moment, the distance between them shrinks with every passing second, not quickly by human standards, but steadily by cosmic ones. You watch the motion unfold in accelerated time. Millions of years pass like drifting clouds. The galaxies gradually grow larger in each other's skies. The gap narrows. The future begins taking shape. One mainstream historical fact is that astronomers confirmed Andromeda's approach by measuring the shift in its light spectrum. Observations revealed that the galaxy is moving toward the Milky Way rather than away from it, making a future encounter essentially unavoidable. Gravity has already decided the outcome. The schedule is flexible. The destination is not. You continue watching. Andromeda grows brighter. Its spiral arms become easier to distinguish. The Milky Way responds in kind. Each galaxy exerts gravitational influence on the other. Across millions of light years, an invisible conversation unfolds. Gravity speaks softly, but gravity never stops speaking. Eventually, about 4 to 5 billion years in the future, the encounter begins in earnest. The galaxies do not collide like automobiles. There is no giant cosmic crash. No spectacular explosion engulfing everything. Galaxies are mostly empty space. Stars rarely strike one another directly. Instead, gravity gradually reshapes both structures. Their spiral arms stretch and distort. The streams of stars arc outward. The galaxies begin transforming. You observe the process unfold. The first close pass creates enormous tidal structures. Long stellar tails extend across space. Gas clouds compress. New waves of star formation ignite. Entire regions blaze with newly born stars. The galaxies become magnificent chaos. A quirky tidbit emerges from astronomical simulations. Some researchers have jokingly referred to the future merger as the Milkomeda event, combining the names of the Milky Way and Andromeda into a single hybrid nickname. Astronomers occasionally reveal unexpected creativity when naming things, at least compared with Object 472b. You continue watching the merger progress. Billions of stars change their orbits. Clusters shift position. Dark matter halos overlap and interact. The structure of both galaxies evolves dramatically. Yet, despite all this upheaval, direct stellar collisions remain unlikely. Imagine two swarms of bees passing through one another, where each bee is separated by hundreds of kilometers. The swarm structures interact. Individual impacts remain rare. Space is astonishingly empty. Even inside galaxies, historians still argue whether future observations will significantly revise details of the predicted Milky Way-Andromeda merger. New measurements continue refining the galaxy's motions, though the general expectation of a future encounter remains widely accepted. The precise choreography may change. The dance itself appears inevitable. You watch as multiple passes occur. Each encounter alters the galaxies further. Their elegant spiral structures gradually fade. The familiar forms disappear. The Milky Way you know today ceases to exist as a recognizable spiral galaxy. Andromeda experiences the same fate. Something new emerges. A larger galaxy, a different galaxy, a merged galaxy. The result will likely resemble a giant elliptical or lenticular system rather than the graceful spirals visible today. The future local group acquires a new dominant member, one formed through billions of years of gravitational evolution. You pause to consider the timing. This merger will occur roughly around the era when the Sun approaches the end of its main sequence lifetime. Earth's distant future is already uncertain by then. The galaxy itself will be changing on equally dramatic scales. Cosmic history never stands still. You continue observing. The merged galaxy expands across hundreds of thousands of light years. Its halo grows larger, its stellar population increases, its central regions become more massive. The future system may contain around 1 trillion stars, perhaps more. The exact numbers remain uncertain. But one thing is clear, the resulting galaxy will dwarf the Milky Way of today. The story of galactic size does not end with current measurements. Growth continues, mergers continue, evolution continues. The universe remains a work in progress. You pull back farther. The merging galaxies now appear as part of a broader cosmic landscape. Smaller companions orbit nearby. Dark matter halos overlap across immense distances. The local group itself evolves. Structures combine. New configurations emerge. Everything changes given enough time. Even galaxies, perhaps especially galaxies. The Milky Way often feels permanent from a human perspective. Stable, enduring, familiar. Yet when viewed across billions of years, it becomes clear that permanence is an illusion. The galaxy is temporary. Its current shape is temporary. Its spiral arms are temporary. Even its future merger is merely another stage in a longer journey. Ahead lies an even deeper question. Where exactly does the Milky Way end? Its visible stars occupy only part of its domain. Its dark matter halo extends far beyond. Its influence fades gradually into surrounding space. The farther you look, the less obvious the boundary becomes. Soon you will venture toward those uncertain edges. Toward regions where the galaxy dissolves into darkness. Toward the frontier where definitions become difficult and the true scale of the Milky Way grows even more astonishing. For now, though, you watch two giant galaxies moving slowly toward a future written by gravity, a future billions of years away, a future already underway. You watch the future merger of the Milky Way and Andromeda fade into the distance, leaving behind a deeper question. Where does a galaxy actually end? At first, the answer seems obvious. Surely the boundary is wherever the visible stars stop. Surely there must be a clear edge, a line, a border, a cosmic fence politely informing travelers that they have officially left the Milky Way. But the universe rarely provides such conveniences. The farther you explore, the more elusive the answer becomes. You turn your attention back toward the present-day Milky Way. From afar, its spiral disk glows brilliantly. The central bulge shines. The spiral arms stand out against the darkness. These visible structures are easy to recognize. They feel tangible, definable, measurable. Yet beyond them lies something much harder to pin down. The galaxy continues. One mainstream historical fact is that astronomers gradually discovered throughout the 20th and 21st centuries that galaxies often extend far beyond their visible stellar disks through halos of stars, gas, and dark matter. What appears to be the edge is frequently only the beginning of a larger structure. You drift outward once again. The bright spiral arms slowly fade. Stars become less numerous. The disk loses its sharp identity. Darkness grows, yet scattered stars remain, ancient stellar streams remain, globular clusters remain, the halo remains, the galaxy refuses to end neatly. It simply becomes more diffuse, more subtle, more difficult to define. You travel farther. The visible disk now looks like a distant city seen across an enormous plain. Yet the Milky Way's gravitational influence still reaches your location. The galaxy still matters here. Its presence remains detectable. Gravity does not care whether something is bright enough to photograph. Gravity cares about mass, and mass extends much farther than visible starlight. A quirky tidbit appears from astronomical research. Some astronomers have compared defining the edge of a galaxy to defining where a fog bank ends. Close to the center, everything appears obvious. Near the outskirts, the distinction becomes increasingly subjective. The analogy is surprisingly effective. Galaxies fade. They do not stop. You continue outward through the halo. Dark matter dominates the environment. Though invisible, it contributes most of the galaxy's mass. Its distribution stretches across enormous distances. The Milky Way's dark matter halo likely extends several 100,000 light-years from the center, possibly farther. The exact boundary remains uncertain. This means the galaxy's true physical influence reaches far beyond the familiar spiral disk visible in photographs. Many people imagine the Milky Way as a beautiful spiral. They are correct, but incomplete. The visible spiral is merely the brightest part of a much larger structure. It is the illuminated downtown district of a vastly larger metropolitan region. Historians still argue whether future observations will significantly alter current estimates of the Milky Way's outer halo. Improved measurements continue refining the picture, and some uncertainties remain regarding the galaxy's most distant regions. The edge keeps moving as knowledge improves. You continue drifting into increasingly sparse territory. Occasional stars appear. Ancient stellar streams stretch across the darkness. Fragments of past galactic mergers linger like faint memories. The halo preserves records of long-forgotten encounters. Even here, the Milky Way's history remains visible. You look back, the galaxy appears smaller than ever. Its bright disk occupies only a tiny portion of its total domain. The halo envelops it like a vast, invisible kingdom. The realization feels profound. The Milky Way is larger than it looks, much larger. Every time astronomers develop better instruments, they seem to discover that galaxies extend farther than expected. Nature repeatedly chooses abundance. You continue outward until another perspective emerges. The boundary between the Milky Way and surrounding intergalactic space becomes increasingly difficult to define. At what point does the galaxy truly end? Where does the local group begin? Where does one gravitational influence give way to another? The answers depend partly on definitions. Different measurements emphasize different aspects. The virile stars, dark matter, gravity, gas. Each tells a slightly different story, and that is perfectly normal. Reality often resists simple categories. The universe delights in gradients. You drift farther into the darkness between galaxies. The Milky Way now resembles a luminous island floating in an enormous cosmic ocean. Its spiral arms remain visible. Its halo stretches outward. Its influence reaches far beyond what the eye can perceive. And yet even this immense structure occupies only a tiny fraction of the observable universe. That realization awaits just ahead, because after exploring spiral arms, star clusters, black holes, halos, and galactic collisions, one final perspective remains. You must step back far enough to compare the Milky Way with the wider cosmos itself. Only then does the true scale become clear. Only then can you appreciate how something 100,000 light-years wide can simultaneously be unimaginably large and astonishingly small. For now, you linger at the uncertain frontier where the galaxy fades into darkness. No sign marks the boundary, no wall blocks your path. The Milky Way simply grows thinner, softer, and more diffuse until it blends into the vastness beyond. And somewhere within that fading glow remains the tiny spiral arm where humanity began asking questions about the stars. You continue drifting away from the fading edge of the Milky Way until even its enormous halo begins to shrink behind you. The galaxy that once seemed impossibly vast now resembles a distant island of light. Its spiral arms blur together, its central bulge becomes a bright knot, its hundreds of billions of stars merge into a single luminous glow. And for the first time you can compare it not with planets, not with stars, not even with neighboring galaxies, but with the universe itself. The perspective is humbling. The Milky Way spans roughly 100,000 light-years across its visible disk. Its halo extends much farther. Its mass influences regions hundreds of thousands of light-years away. It contains hundreds of billions of stars, perhaps trillions of planets, a supermassive black hole. Ancient globular clusters, vast clouds of gas, immense reservoirs of dark matter. From any ordinary viewpoint, it is almost beyond comprehension, yet the universe contains far more. One mainstream historical fact is that astronomers in the 20th century gradually established that the universe contains not just one galaxy, but countless billions of them. Observations by astronomers such as Edwin Hubble revealed that many faint smudges once thought to be clouds inside the Milky Way were actually entire galaxies in their own right. The universe expanded overnight, at least conceptually. You continue retreating, more galaxies become visible. Some are spirals, others are elliptical giants, others are irregular collections of stars and gas. Each possesses its own history, its own structure, its own population of stars. The Milky Way joins a vast cosmic population. Suddenly, home becomes one member of a much larger family. A quirky tidbit emerges from modern astronomy. Some of the largest known galaxies are so enormous that they can stretch across millions of light years and contain trillions of stars. Compared with those giants, the Milky Way appears almost modest. Not small, never small, just not the largest participant in the cosmic competition. The universe apparently subscribes to the philosophy that if something is already huge, it might as well become even bigger. You continue observing. Galaxies cluster together. Clusters join larger structures. Filaments of galaxies stretch across hundreds of millions of light years. The observable universe reveals a web-like architecture of astonishing scale. The Milky Way becomes a single luminous dot within a much larger pattern. And yet that tiny dot remains extraordinary, because it is your dot. The place where every human who has ever lived spent their entire existence, every city, every mountain, every language, every song, every dream, contained within one galaxy among billions. Historians still argue whether future discoveries will significantly alter current estimates of the total number of galaxies in the observable universe. Improved observations continue refining the picture, and the true count remains an active area of research. The universe keeps resisting final answers. Perhaps that is part of its charm. You look back one last time. The Milky Way glows softly in the darkness. A spiral city of stars, a structure so large that light requires 100,000 years to cross it, a system containing distances that overwhelm ordinary intuition. And yet after this journey, the number feels different, not smaller, simply more familiar. You have traveled its spiral arms, visited its crowded core, watched stars orbit Sagittarius A, explored the halo, drifted among globular clusters, measured galactic years, met neighboring galaxies, witnessed the future collision with Andromeda, reached the uncertain frontier where the galaxy fades into darkness. The Milky Way no longer feels like an abstract statistic. It feels like a place, a vast and beautiful place. And perhaps that is the most remarkable realization of all. Human beings evolved on a small planet, orbiting an ordinary star located far from the galactic center. Yet somehow they learned the size of the galaxy, mapped its structure, measured its motion, discovered its history. And imagine journeys like the one you have taken tonight. Not bad for a species that occasionally spends 10 minutes searching for a phone already sitting in its hand. You allow the final view to linger. The galaxy hangs in silence. The darkness around it stretches endlessly. The stars continue their ancient dance. Everything moves. Everything changes. Everything belongs to a story much larger than itself. And now, as the journey draws gently toward its close, you let the vast scales soften. The numbers become less important. The distances become less demanding. The galaxy becomes simply a quiet presence in the night, a river of stars, a home among the darkness. The Milky Way drifts peacefully before you now, no longer something to measure, but something to rest beside. Its spiral arms turn so slowly that they seem still. Its ancient stars glow with steady patience. Its halo fades gently into the surrounding darkness. You imagine floating there, weightless and calm, with no destination to reach and no calculations left to make. The immense distances that once felt overwhelming now feel strangely comforting. There is no rush in a galaxy 100,000 light-years wide. No need to hurry across cosmic oceans. The stars have all the time they need. And tonight, so do you. Far below, the sun continues its quiet orbit around the galactic center. Earth continues turning beneath its blanket of atmosphere. Cities glow. Oceans breathe against distant shores. Night settles over countless landscapes. And above them all stretches the Milky Way, carrying every familiar thing through the universe. The galaxy does not notice the passing centuries. It does not count the years. It simply continues its gentle journey through the darkness, surrounded by silent stars and ancient light. You let that image grow softer now. The spiral arms blur into silver mist. The central bulge becomes a warm glow. The darkness around it feels peaceful rather than empty. The universe grows quiet. The stars grow distant. And somewhere within that vast river of light, your small corner of the cosmos drifts safely onward. May your thoughts slow like the turning galaxy. May your worries fade into the darkness between the stars. And may you rest tonight beneath a sky that has carried wonder for countless generations. End of script. Sweet dreams.